So welcome back, and we talk about this graph on Tuesday, and to use this graph to solve problems that we have a SOP or standard procedure. First of all, we assume there is no motion, and we determine F and R, and then we determine mu s times R, which is the maximum friction. If F is smaller than mu s times R, which is this part, that it means that we have no motion. That assumption is correct. But if F here is greater than mu s times R, which is impossible, that means we have motion, and F is equal to mu k times R. Now, that's how to work on it. So let's work on an example. This is example problem 8.1. Now we have a block here which is its weight is 300 Newton, and and it is placed on an inclined plane. Incline means 斜啊。或坡度。The coefficient of friction between the block and the plane mu s equals to 0.25 and mu k is equal to 0.20. Determine whether the block is in equilibrium. The block here is in equilibrium, and determine the value of the friction force. Now, determine whether the block is in equilibrium. So if there is motion, it means it is not in equilibrium. Okay, motion means not in equilibrium. Of course, it means F equals to ma and so on, but so it is not in equilibrium. And determine the value of the friction force, or find the value. That it means determine, right? Not in equilibrium, it means summation F does not equal to 0. And of course, in equilibrium means summation F is equal to 0. So there is a 300 Newton force here, and the incline we know the slope of the incline plane. I'm not sure whether you know the word slope. Slope means 斜率. And we have a 100 Newton force pushing up here. Now, any problem with the question? Anything that you don't understand here about the question? If you're okay with the question, then let's go on with how to solve it. How to solve the problem? Now, first of all, should we assume there is no motion, or should we assume we have motion? No motion, okay? Sorry. Assume no motion. That means summation F equal to 0. The first step, we need to assume something, because it can be in motion or it can be no motion. So First of all, we assume we have no motion here. So summation F equal to 0. So after we assume summation F equal to 0, once we write this equation, what do we need? Once we write summation F equal to 0, we need a free body diagram. Okay? So we need a free body diagram. Here, so we have a free body diagram. And what forces do we need to draw here? So we have the weight of the block is 300 Newton. Any other forces? And in the question that we have 100 Newton pushing up, so we have 100 Newton going up here. Any others? Because the resultant force of this one and this one does not equal to 0, so we must have other forces, right? We have other forces. So we have because it is placed on a plane, so it is in contact with the plane, so it has a support reaction here. And because in this problem we are talking about friction, so we know we have friction. So and we assume first we can assume the friction is going down as we want to push the block along the plane. So we want to push the block along the plane. So we can assume the friction is going down. We assume friction is directed down and to the left. So we have F here. So these are the four forces in this problem. Now, in this, in the first step, we need to determine F and R. The friction required for equilibrium, and the normal force, the support force here. So these are 80 and 204 newtons. I think you know how to calculate this, but remember to write these two expressions, okay? Remember to write these two. So I think once you have this free body diagram, I think you can do this on the next step. In the next step, we calculate the maximum friction force. So what is the maximum friction force? In a problem like this, what is the maximum friction force? Let's look at the two pages to the back. We look at the graph again. So what is the maximum friction force? Mu S times R. Okay. Mu S times R in this is the reaction force. Reaction force here. So the maximum friction that can be applied is Mu S times R. Therefore, in this in our question, it means maximum friction force is equal to mu s times n. In this case, because mu s is equal to 0.25, because mu s is equal to 0.25, it is equal to 0.25 times 240 Newton. It is equal to 60 Newton. Now we compare this to the friction required for equilibrium is 80 Newton and the maximum friction force is 60 Newton. So is this possible? No, it is not possible because the maximum friction force is 60, but so we need 80 to for equilibrium. Therefore, the maximum friction force is smaller than friction required for equilibrium. Therefore, the block slides. But we need to determine the sliding direction of the block. You first write it down. Please take your time to write it down first, and I will talk about it. Talk about the next step. After you write it down, please think about whether it slides up or slides down. So does it slide up or does it slide down? Up or down? So let's have a look. Let's have a look. Now for equilibrium, let's draw this case. Let's draw this case for equilibrium. It is for equilibrium. Oh, sorry, that this is not very pretty. And here this is 100 Newton, and we have N, and we have that 300 Newton. And for this friction force, the friction force, remember in this case, friction force is 80 Newton going up. So this is 100 Newton, and this is N is 240 Newton, and wait a minute, I'm sorry. And this one is 300 Newton, and this is 80. The 80 Newton here is going up, okay? But we say that the maximum friction force is 60 Newton, so we cannot have 80 Newton here, but we can only have 60 Newton here. Okay. So in this case, we say we need 80 Newton to keep it here, but now we only have 60 Newton. So the block will go down. Because if it goes up, then it should be higher than 80 Newton. And if there's only 60 Newton, then it goes down because we don't have enough force to keep it here. So in this case, the block slides downward. It's okay because it looks a bit strange, but it is logical because the 80 Newton is for top here. So for this it means it has motion. If it has motion, then we still have one step to do. We still have one thing to do here. Because if it has motion, the friction force is equal to what? Friction force is equal to mu k times r, which is 0.2 times 240 Newton, which is 48 Newton. So F is equal to 48 Newton to the 37 degree. This is just for a. This is arc sine of 0.6. Take your time to write it down.